do an example of calculating a displacement. Displacement is a vector that it takes you from your initial position to your final position. And the displacement only depends upon those final and initial positions. In this example, it's displacement that's built up out of 3 different steps of the motion of a prairie dog. You could build a displacement out of an infinite number of steps if the object undergoing the motion is following a smooth curve. But regardless of how you get to your final position, the displacement is always just the vector position for the final position minus the vector for the initial position. In this one, we are to construct the displacement vector and calculate its its magnitude of the displacement. We're not going to calculate a direction because this is actually in 3 dimensions, and we have to specify 2 angles to do that, which is a little beyond the pay grade for this course. All right. We start off by drawing coordinates so we can put our vectors in some semblance of order. So we can take x to be the east direction, y to be the north direction, and z is coming out of the plane of the page. My notation for vectors in 3 dimensions is a circle with a dot. That means that you're seeing the vector head coming at you, like the arrowhead coming at you. So that is a vector out of the page. And if you see the other end of the vector, you're seeing the fletching, the tail feathers on the arrow, then you are seeing a vector into the page. All right. So out of all those motions that the prairie dog undergoes, I'm going to say that he starts at my origin of coordinates. So that will make the calculation a little bit easier. So I'm saying that the initial position is a 0 vector. The first motion is to go 5 meters west. So there's R1. And I'll write out R1 in components in my coordinate system. That is going to be minus 5 meters relative to the x direction. Next motion of our prairie dog is that the prairie dog goes southwest for 8 meters. So there is the second step. So southwest is equal parts west, equal parts south. So that's a 45 degrees. So I can write out position vector 2 for that motion is 8 meters over root 2 on the x direction, and then minus 8 meters over root 2 on the y direction. And sine of 45 degrees is cosine of 45 degrees is 1 over root 2. So that's where the square root of 2 got there. And then the last motion of the prairie dog is to jump safely home. And so that is a position vector going into the plane of my page. And the problem says that the prairie dog drops down 1 meter. So it's going to be 1 meter along minus z direction. Okay. So the final position is the vector sum of r1 plus r2 plus r3. Go through all those motions. And the final position is a vector in space. I'm going to have a minus 5 meters plus 8 meters over root 2 relative to the x direction. I'm going to have a minus 8 meters over root 2 relative to the y direction, and then dropping down a meter means 1 meter relative to that positive z direction. My displacement vector is my final position minus my initial position. And so whatever we picked for the initial position in this problem, we're going to subtract it off now. I picked it to be the 0 vector. So that just goes away. And our displacement vector is the same as the final position vector, but I'll write that out just for completeness. Minus the quantity 5 meters plus 8 meters over root 2 relative to the x direction, minus 8 meters over root 2 relative to the y direction, and then minus 1 meter relative to the z direction. All right, and then we are asked to calculate the magnitude of this vector. So I want to go through and do that. The magnitude of the vector delta r, that's how we would write it in our notation. So it looks like the absolute value of the vector delta r. We're going to use the Pythagorean theorem for all three of those perpendicular components of x, y, and z. So I'm going to have 5 meters plus 8 meters over root 2, quantity squared, plus 8 meters over root 2, quantity squared, plus 1 meter, quantity squared, and square root of all of their sums. And that will give me a magnitude of the displacement vector of 12.1 meters. And we're not finding a direction in this case because for me to do that correctly it would involve finding two angles. You think of it as like an angle in the XY plane, and then I would need another angle to tell me the direction above or below the z equals 0 plane. So we're not going to specify that, but it's easy enough to calculate the magnitude of the displacement vector.